Good afternoon, ladies and gentlemen. Welcome to my talk. I'm a program manager, as introduced at Holst Center, where I lead activities around laser-assisted microcomponent integration, high-throughput solutions, and our primary application domain is in MicroLED assembly and repair solutions. So as I introduced, I'm from Holst Center, TNO, and I would like to just say a few words about Holst, the R&D institute I'm representing. It's been founded back in 2005 by two mother organizations, being TNO and IMEC. We have around 280 employees, mostly all located in these premises at High Tech Campus TNO. And well, within the organization, within the Holst Center, and I'm representing TNO part of it, we have two expertise groups, and there is a reason why I want to present this slide. It will become clear in a minute. Two expertise group focusing on two aspects. One, within hybrid printed electronics, we've been a pioneer and still are pioneering work in printed electronics and hybridization, so bringing silicons and discrete components, could be LEDs, onto the freeform electronics. While on the other hand, we also have been having over dozens of years, decade of the experience in thin film processing. We've been pioneering in ultra-bendable OLED displays, maybe recent work on curved photodetectors and X-ray detectors. But the bottom line of it, really synopsis of these two research groups that enabled us to develop our proprietary release stack to enable laser solutions for micro-LEDs. So within Holst, we've been following the trend in miniaturization of LEDs, and we started pioneering that and creating, the slide shows, right? It's a bit jumpy. Yeah, that's cool. No. I've been pioneering work on creating ultra-stretchable displays using a discrete, rather large LEDs, then creating more solutions by combining mini LEDs and just conventional pick-and-place solutions onto the printed circuit with using ultra-fine mesh screen printing to have a semi-transparency. However, as we all know, semi-transparent is still semi-transparent because there's a circuit. You can make it much, much finer. There are solutions for that. However, LEDs as a light source still is visible even in on-off state. And making the next step, for instance, already in a signage, MicroLED has an entry, but beyond that, we have heard so many talks about regular MicroLED displays and challenges all the way. So I just highlighting, maybe connecting to the previous speaker, there are two worlds. One is MicroLED display with a huge challenges, but there is also chip-first approach that can solve potentially some of this, but they're also in the middle, somewhere where you can do still quite reliably, but with relatively larger components. I'm not talking about 5 and 6 micron components, but relatively large for signage. And that's what we are developing at Holst Center as a primary application domain. However, it's of course solution that I would like to present is also applicable as some of the flavors, for instance, for repair of the ultrafine components as well. Well, we heard components are small, micro-LEDs are small. We have to live with that. And to assemble and integrate one way or another, whether it's a chip first or flip chip, you need ultra-high precision, either in a primary step for repitching or afterward or during the flip chip during actual transfer. Then components themselves on a native, they're in ultra-high densities, only a few microns between the components, while products themselves will be having a different densities, right? So repitching step, as previous speaker has mentioned, needs to be realized, and it is a process by itself. Then, well, no one likes dead pixels in a display, so we would like to repair. And repair you can embed into the pixel, that's one of the solutions with the intrinsic redundancy, or solve it on demand. Solve by placing the twin dies to only the ones that failed, right? So having ultra-high selectivity for repitching and for repair would be great, and having it in high throughput. So with these kind of boundary conditions and requirements at hand, I would like to present you to our solution. That there have been multiple talks during the conference already addressing the use of lasers, and there are different solutions. Our solution is based on a co-development of our proprietary release stack in combination with a low-cost laser solution. So I mean that low cost meaning in orders of 10K lasers rather than hundreds of K, just to give you a reference.